The Earth's surface temperature is increasing, glaciers are melting, ocean levels are rising. We're experiencing a climatic warming so rapid, none like it has ever taken place. What will the impacts be, and to what extent has humanity contributed to this phenomenon? The Earth's climate has always been subject to large fluctuations. Changes in natural factors can trigger warm periods as well as ice ages. But much indicates that, along with natural cycles, human influence is undoubtedly responsible for the current temperature increase, mainly due to large-scale emissions of greenhouse gases beginning in the Industrial Revolution. The concentration of carbon dioxide in the air hasn't been this high in 800,000 years. This impacts the naturally occurring greenhouse effect and with it the temperature. The greenhouse effect is vital in that it makes life on Earth possible. Without it, the average temperature on the Earth's surface would be about -18 degrees Celsius. Energy reaches the Earth primarily in the form of short-wave sunlight, some of which heats the atmosphere directly or is reflected back. About half of it reaches the surface of the Earth, where it's converted into heat and in the form of long-wave infrared radiation sent back out into space. This is where greenhouse gases, such as carbon dioxide, methane, nitrous oxide and water vapor, come into play. Unlike nitrogen and oxygen, which together make up about 99% of the atmosphere, greenhouse gases can absorb infrared radiation and then re-emit it. In this way, they hold some of the sun's heat in the lower atmosphere, just as a greenhouse does.
Quite clearly, in just a few decades, without CO2 and these other greenhouse gases, the water would condense to such an extent that the average temperature would actually be below this -18 degrees Celsius. Why below? Because it would be a lot of snow, and that reflects even more solar radiation. So that's why we consider carbon dioxide actually and the other greenhouse gases that do not condense. It's a climate thermostat. And there's a lot of information from geological timescales, paleoclimate studies that strongly corroborate this. That's why we worry about carbon dioxide.
When climatically active gases like CO2 increase in concentration, the natural greenhouse effect intensifies and it becomes warmer. The Earth's system responds quite sensitively to small deviations. During the last ice age, the average global temperature was only around 4 to 8 degrees colder than it is today. Even slight changes can set off complex reactions and interactions, as we can see from the oceans. Since the Industrial Revolution, they've absorbed around 50% of worldwide CO2 emissions, thereby slowing global warming. But when water quickly absorbs large amounts of carbon dioxide, the pH value falls, the oceans become acidic, which threatens calcifying organisms. This carries long-term, far-reaching consequences for the ocean's ecosystems and food chains. In addition to CO2, our oceans also absorb large amounts of heat. As the temperature rises, the solubility of gases in the water decreases. In the long term, then, more CO2 will remain in the atmosphere, which will accelerate global warming. The process is a vicious circle. An additional aspect of this self-reinforcement is the ice albedo feedback. As more Arctic ice melts, there's less of it to reflect sunlight. Temperatures increase, which melts more of the ice. Conversely, an increase in the surface area of the ice caps would lead to lower temperatures. Even today, the complex cycles and interactions of the Earth's ecosystems are not fully understood. Moreover, the climate is too diverse to be able to depict it with scientific models or to be able to prognosticate. Despite this uncertainty, most scientists deem current knowledge so conclusive that the human-created greenhouse gas emissions are acknowledged to be the main cause of global warming. The long-term global character of the temperature shift and the measurable cooling of the stratosphere are interpreted as signs of mankind's fingerprint.
An important part of the proof has to do with computer models. You model the entire climate system. It's very complicated. That's why you're not absolutely certain. But the consistency is all there. So the conclusion, again, just to emphasize it, is that it is human activities that are changing the climate. That's a consensus of the well-informed scientific community, which is also very well documented in the literature. And there are remarkably few, if any, scientific papers, I would call them pseudo-scientific papers, that really put a serious question on these conclusions, admitting again that, yes, there is some probability that it might have happened naturally.
If in the near future we see no drastic reduction of CO2 emissions, by the year 2100, the Earth's temperature will be more than 2 degrees higher than pre-industrial levels. In reaching this temperature, we will have brought about a climate absolutely unique in the history of mankind. The Earth's conditions, so favorable for life, could dramatically change. Some foreseeable consequences would be an ice-free Arctic in summer, the further rise of ocean levels, and more frequent extreme weather events, such as torrential rains, heat waves, and floods. Many people will have to leave their homes and become climate refugees. Infrastructure and the availability of food and water could also become problematic. Poorer areas and developing countries especially will likely be more severely affected. Worldwide recessions and societal disruptions could also occur. Extraordinary challenges for politics, economics, and the world community.
Even on a moderate scenario of warming, we may expect to see the progressive breakdown of civil society across the planet by indeed 2100. The predictions are quite dire. Water, of course, is a major component of it, and the poor of the planet are going to be the most severely impacted, as always. So I think it's a very real issue for all of us, and it's something that we have to drive forward.
The first United Nations Conference on the Human Environment, which marks the beginning of global environmental policy, took place in 1972 in Stockholm. Since then, there have been many more conferences and some milestones, but it's very hard to reconcile the interests of all countries. Since 1988, the Intergovernmental Panel on Climate Change regularly summarizes the state of scientific knowledge and advises international decision-makers. Means to achieve a drastic reduction in greenhouse gas emissions are priority number one. Climate change adaptation is also a central objective in governmental policy. How can poorer nations be aided? How will we preserve living space? Who will pay for climate-caused losses? In Lindau too, the topic of global warming is often discussed. On the 3rd of July 2015, during the concluding ceremony of the 65th Lindau Nobel Laureate meeting, numerous Nobel laureates signed the 2015 Minot Declaration on Climate Change.
We believe that the nations of the world must take the opportunity at the United Nations Climate Change Conference in Paris in December 2015 to take decisive action to limit future global emissions. This endeavor will require the cooperation of all nations, whether developed or developing, and must be sustained into the future in accord with updated scientific assessments. Failure to act will subject future generations of humanity to unconscionable and unacceptable risk.
In December 2015, at the start of the UN Climate Change Conference in Paris, the document, with 72 signatures, was presented to France's President François Hollande. That conference represents a meaningful achievement. For the first time, uniting the world's nations together in a global climate treaty became a reality. The Paris Agreement could be a historic step. If the covenants are rigorously implemented, it could herald a reversal in fossil fuel energy production.